Why do Netflix and Amazon obsess over something as boring as random sampling? Because if they get it wrong, they don't just lose data, they lose millions. I've seen entire features shipped based on biased tests that teams spent months cleaning up. Today, we're fixing that. We're going from raw distribution to A/B testing cohorts to make sure your analysis actually survives the boardroom. All right, imagine you're a product manager at a growing startup. You've got 20 users. Look at them on the right. Different genders, different cities, different ages. Assume this is your entire user base right now. Your dataset consists of 20 users with specific attributes. The slide calls out the key attributes: gender, city, and age. And your CEO just walked in and said, "We need to test a new feature. Split them into 2 groups. Make it fair." Pause the video. What's your move? How do you split 20 people fairly? Here's what most people do wrong. They manually pick. Okay, 5 men here, 5 women there. A few from Delhi, a few from Mumbai, and boom, you just introduced human bias. You're now testing your opinions, not your product. What to do then? Random sampling. You let the algorithm decide. No bias, no favoritism, just pure statistically valid distribution. And that's exactly what makes your test results defendable in post-launch reviews. This is why data teams exist, because one biased test can kill a launch. So, how do you actually do random sampling in the real world? Look at the flow on the right. You've got your user pool, those 20 people. You throw them into a randomizer and it spits them out into group 1 and group 2. Clean, simple, fair. Now here's where it gets tactical. The slide shows you 2 methods. Method 1. If you're in Excel, you use the formula equals rand between 1, 2. Every user gets assigned a 1 or a 2. Boom, random groups. Method 2, if you're in Python, you use random.choice. Same logic, different tool. Every user gets an equal shot at landing in either group. That's a 50-50 coin flip, scaled to 20 people. And here's the result. Equal probability for every user. You're not cherry-picking high spenders or filtering out Android users. You're treating every data point like it matters, because it does. And when your VP asks, "How did you ensure this test was unbiased?" you point to this. You show them the randomizer. You show them the code. That's how experiments survive audits. All right. Here's where randomness shows its power. Look at the 2 groups side by side. Group 1, total count 10 users. Average age, 27.5 years. Gender split, 50% male. Group 2, total count 10 users. Average age, 26.5 years. Gender split, 50% male. See that? The randomizer didn't just split people, it balanced them. The attributes are nearly identical across both cohorts. Now pause and think about this like a detective. If Group 1 had an average age of 35 and Group 2 had an average age of 22, and you tested a retirement planning feature, which group do you think would engage more? Group 1, exactly. You'd see a huge difference, but it wouldn't be because of your feature. It'd be because of age bias. Your test would be invalid. Your insights would be garbage, and your CEO would greenlight a feature that bombs in the real world. Here is the key takeaway. Random assignment balances characteristics on average. That's not luck, that's math. You're not manually engineering balance. You're letting probability do the heavy lifting. And over thousands of users, this works like clockwork. This is what separates real experimentation from guesswork. Now let's connect this to real money. The slide breaks it down perfectly. Group 1 becomes the control group, A. They see the old version, the baseline, the thing that's already making you revenue, marked with a shield icon for stability. Group 2 becomes the test group, B. They see the new feature, the risky bet, the thing you hope will 10x conversions, marked with a rocket icon for innovation. Now here's what matters most. Cohorts are statistically similar at the start. That's your foundation. That's your proof. And the fourth point? Used to measure impact of product changes. Because both cohorts are statistically similar at the start, any difference you see in behavior? That's caused by the product change. If randomization is done properly, the only variable separating the two cohorts is the experiment. If you don't randomize, you can't isolate. If you can't isolate, you can't prove causation. And if you can't prove causation, you're not a data professional. You're just someone with opinions and a laptop. Type yes if you've ever run an A/B test before. Let's address the elephant in the room. The common doubt. Do the groups contain unequal numbers of premium users? That's the fear, right? What if randomization accidentally stacks all your high-value users in one group? That concern is valid in non-random sampling, but in random assignment, every user has an equal probability of falling into any group. Here's the reality, and this is beautiful. Random assignment naturally filters out and removes systematic bias. There's no natural bias favoring one group over another. Thus, challenging cohort fairness in such setups doesn't hold. The randomization process itself guarantees unbiased and representative groups. And here's the result. Metric differences are caused by the product change only, not user types. You're no longer confusing correlation with causation. You're no longer saying, oh, Group B converted better because they were younger. Nope, Group B converted better because your feature worked. This is the foundation of every growth strategy at every major tech company. This is advanced level thinking. This is how your experiments survive executive scrutiny. All right, let's lock this in. 3 professional takeaways. First, random sampling creates statistically balanced groups. You're not engineering fairness manually, you're letting math do it for you. This is how you scale experiments from 20 users to 20 million users without losing validity. Next, A/B test differences are attributed to product changes, not user demographics, not time of day, not luck. Your feature either works or it doesn't. And randomization is what gives you the confidence to say that in a boardroom. Next, randomization ensures unbiased, fair cohorts. This isn't just about being ethical, it's about legal compliance, regulatory approval, and investor trust. If this clicked for you, hit that like button. It tells YouTube to push this to more people who need it. And subscribe because we're dropping advanced data concepts like this every single week. This is what real analysts do. This is how experiments survive audits. This is the difference between students and professionals. Now go build something that scales.